Very good afternoon, everyone. So today I'll be presenting my journal on topic the cost of chewing, the energetics and evolutionary significance of mastication in humans. So this was article which was published in the year 2022 in the journal called Science Advances, which is impact factor of 14.1. So these are the terminologies. Mastication we all know. Respirometry is the measure of the metabolic rate through the oxygen consumption and carbon dioxide production, that is PCO2. Electromyography is EMG. It records the muscle activation. Example during the masseter muscle during chewing. And BMR involvement is the energy expenditure at rest. And TEE is total energy expenditure. That is the daily energy use, including the BMR activity and the digestion. So the novelty of the study is its first study to quantify metabolic costs of chewing in humans. So it links chewing energetics to evolutionary adaptation. Example, deprivation, morphology, and so it uses tasteless or odorless gums to isolate the chewing cost from digestion or sensory effects. So the aim of their study was to measure the metabolic cost of chewing and its evolutionary implications and significance. The objective is to quantify the energy expenditure, that is EE, during chewing and during the respiration using respirometry, to compare the EE for soft versus stiff gum substrates, to relate the EMG data during masseter activation to metabolic costs, and to extrapolate the findings to ancestral hormonal diets. So the materials of anthropology which was used to study is there were 21 healthy adults, 15 females, 6 males, which were aged between 18 to 45. Major dental surgery in the past year, so people who had major dental surgery were excluded. So they fasted overnight to minimize the digestive metabolic interference. Chewing substance were given. So there were two substances which were used. So they had Suncom tea and Solzma tea. So Suncom is a soft gum, which has an elastic modulus of 89 kPa, which is similar to that of bubblegum, and stiff gum is which is similar to that of chewing gum, which is an elastic modulus which is twice that of soft gum, that is 209 kPa. So the rationale for gum use is that it eliminates the taste or smell triggered digestive responses. So the key measurements, these are the key measurements. So initially they start with the respirometry, that is indirect calorimetry. Omnical system, it measures the oxygen consumption and the carbon dioxide production values. The protocol was they had a 45-minute baseline BMR measurement in supine position with a minimal movement, and then 15 minutes of chewing bouts were carried out using either soft gum or stiff gum, or in the randomized order was also used with 3 groups were in study, and 5 minutes rest between the trials to avoid fatigue was also given. So the EE was calculated using the Wales equation, and then it was analyzed. Secondly, we had the electromyography, that is the EMG, where they used wireless electrodes on the masseter muscle. The signal processing, it used raw EMG data, which then rectified the data through the low pass filter, and the amplitude peaks were also identified. The muscle activation for chew cycle was identified and they were noted. Fourier transformation for chewing frequency was also used. Plus they also use ultrasound to measure the relaxed or tense masseter thickness. So it is a proxy for muscle size. So they ran statistical analysis. The tests used were repeated measures ANOVA, which compared the EE values with that of the basal BMR, soft gum and stiff gum. The result is that there was a significant difference between groups, and they also used Morphology's post hoc test, and all pairwise comparisons were significant. And then they used one sample T test where EMG amplitude or frequency ratios it differed from 1, so the P value was significant. And then they also used linear regression in the study, and they noted that there was no link between masseter size and MEP. Since the P value was not significant, it suggested muscle size doesn't predict relative chewing efficiency. So the results of the study were the metabolic cost. That is, with chewing it increased the EE by 10.2% in the soft gum and 15.1% in stiff gum above the BMR, and the stiffer gum it required greater muscle activation, that is EMG, higher EMG amplitude. The muscle, as for the muscle activation, the stiff gum it context which is basically identified in the study. It was compared to modern humans. So the chewing cost was lesser than 1% of TEE, which is approximately 35 minutes per day. So this extrapolated to that of the ancestral diets. That is, it was around 6.6 hours per day like Congo, and which was approximately 2.6% of TEE, which we have in the current day. Moving on to the discussion. So the metabolic costs, while chewing increased EE by 10.2% to 15.1% about BMR, and as said, the sitcom required greater meseta activation, and the chewing cost in modern humans, it is less than, it is approximately 35 minutes per day, but in earlier ancestral hominids like Congo species, it was around 6.6 hours per day. So that is a very huge, significant energy sink which is seen throughout evolution. So this supports the dietary efficiency hypothesis, that is a robust masticatory morphology which is seen in the Australopithecus population may reflect selection from energy optimization. So there is also this technological liberation hypothesis which states that cooking or mechanical processing, it reduces the chewing time, freeing energy for brain expansion. So this is a theory which is called expensive tissue hypothesis. So there is also comparative context which is seen between chimpanzees and orangutans. So chewing raw meat, it costs approximately 2.3 to 5% of energy gain. So it suggests us that pre-processing food, it improves it, but it improves the net energy yield. And the strength of this study is they use innovative methods. Like this is the first study to combine spirometry plus EMG for chewing energetics, studying energetics. And this study also has an evolutionary link since it connects biomechanics to hominid dietary adaptation. And this another strength is that they have control. That is, they have very minimized confounders like digestion, taste, and learning effects. Moving on to the limitation, that is lack of generalizability. So gum is not equal to natural food, as we all know. So like raw meat or plants, they are like even more stiffer than that of the stiffer chewing ones. And samplation, there were sample sizes like really small, and there is like imbalance in the sex distribution and limited age, like 18 to 45 people with 18 to 45 years are only included in the study. And this is also short-term data. Only a 15-minute chewing time was studied, and this chewing bout, it may not directly reflect the ancestral chewing pattern. And future direction of the study, maybe they can test the real foods using raw vegetables or meat, and they comparative studies can be done which measures the chewing cost in non-human primates. And longitudinal data can also be done where prolonged chewing sessions to mimic the ancestral diets can also be studied. And ancestral diet, model energy trade-offs in early hominids can also be studied. They concluded with that chewing is metabolically costly. It scales in regard to the food stiffness. So ancestral hominids, they likely dedicated approximately 1 to 3% of TEE, whereas we only have around 0.6 of TEE during mastication, drying selection for efficient anthropological morphology. So the modern humans, the docile masticatory system, it reflects a reduced chewing demand because we cook food, we have processed food nowadays. So that's also a theoretical implication as well. Evolution of cooking. So pre-processed foods like cutting and cooking, it may have provided an energetic buffer for brain expansion. And as of dental adaptation, a thick and thicker enamel was seen in the Paranthropus species, which could reflect the selection to reduce the chewing costs for tougher foods. So the bottom line is, this is a landmark study with the innovative method, but the generalizability is limited by artificial substrate. So this can open new avenues for evolutionary energetics research. So this study follows stroke guidelines. So it was a basic observational basics and experimental study. So the title, abstract, introduction, methods, they're all like clear. The participants, the inclusion or the exclusion criteria was not well defined, and there was some bias pertaining to the age selection and the gender selection. So dental health details were all not given. So otherwise the variables, data sources, bias, quantitative data, they're all tabulated and given well. The results were not, the raw data was not given, and the participant flow was also results were clearly reported, but raw data accessibility still remains unclear. Otherwise, the discussion and funding part was all well documented.